We are now looking at the equation dn over dt is equal to Rn times the quantity 1 minus n over k. So that is the logistic growth equation. So let's explore what happens as we manipulate k to dn over dt. And remember that k is the carrying capacity for a particular population. If n is equal to k, then this equation, Rn 1 minus n over k, this value is equal to 1. So then we get R times n, 1 minus 1. That would equal 0. So dn over dt would equal R times n times 0, which is 0, so there would be no growth. All right, so what happens when n is greater than k? So let's look at that quantity, R times n, 1 minus n over k. And you can just, again, plug in some values if you want, but as n becomes bigger and bigger and bigger, then this whole quantity is going to get bigger and bigger and bigger, so that 1 minus some very large value is going to be negative. So when we look at dn over dt, it's going to be equal to R times n times some negative value. So it's going to be negative, which means that population will decline. All right, so now let's look and see what happens when n is less than k. So in this case, R times n over 1 minus n over k. All right, so now n is tiny, tiny compared to k. And so as n gets smaller, k becomes larger, and this value declines and gets smaller and smaller. So 1 minus some small value would be relatively large. So we'd have R times n times by some relatively large value. Okay, so then in that case, population growth would be exponential, okay, and would increase.